All right. Welcome to session 3 of the Cloud Native Beers with Engineers. We're super excited to get together and chat with you guys. We're going to be talking today about Cloud Native Operations, which is a store app that you can get off of the Innovation Labs that dramatically eases the process of setting up Kubernetes discovery. We talked a bit about it yesterday, or excuse me, in our last session, but we're going to go much deeper on it today. Couple of quick points. I will let Will introduce his beer here shortly. I am actually on a super strict no beer diet, so
Oh
unfortunately,
no.
yeah, I'm trying to get drop a weight bracket for my next fight. So there will be no beer for me today. I will just enjoy you guys enjoying your frosty beverages. Will, you want to give us the rundown on yours?
Sure. Today I'm trying a wrench, as in the tool, hazy IPA by Industrial Arts Brewing in Beacon, New York.
Nice. It's always fun that there's so many great little local breweries, and I just recently was out in Mancos, Colorado, and had a local cider from out in Mancos, and that was top notch.
Nice.
Um, so let's go ahead and get things moving. Just formality, really quickly. This is we're always talking about forward-looking statements here. As you guys saw in the last couple of sessions, we have a tendency to peel back the covers a little bit and show things fairly deep and in sometimes in futures. So don't make any purchasing decisions or stock decisions based on what we're showing today. This is purely just here for us to all learn together and work together as we go forward. So as again, it's pretty informal. This is our agenda. It's going to continue to stay this way until you guys tell us, hey, let's add this or do this or whatever. But, we'll just quickly cover, why we're here, who we are. We're going to dive into cloud native operations, and then we'll have a Q&A and workshop session at the tail end. So why are we here? This is the same thing as always, but I do believe it bears repeating, right? The whole goal is for everybody to come together and talk about where we're at in our cloud native journey, the struggles that we're kind of trying to overcome while we're here, some of the capabilities that we have, and understand how we can better leverage the ServiceNow ecosystem in order to continue on our maturity path down the cloud native maturity model. So, who we are. If you don't know me by now, Mike Gallagher, I am an ITOM architect. I have been in IT for a very long time. If it has ones and zeros in it, I've probably had a hand in it at some point in my career. Right now, I'm heavily focused on Kubernetes and all things cloud native. And a side note about myself, I spend a lot of time playing board games and training Brazilian Jiu-Jitsu. And actually, my background today is from Tap Cancer Out, which is a cancer fundraiser Jiu-Jitsu tournament that I'll be doing in early June. So I'll post a link on my LinkedIn. If you would care to support me in that, I would be greatly honored. Will?
Will Hallam. I've been at ServiceNow for about a year, in IT for over 2 decades. Currently focusing on automation, and that's what's kind of brought me to the cloud native with ServiceNow world. Public cloud is a great it's kind of like a big set of Lego blocks for IT. And ServiceNow is that little Mindstorm computer brain that they used to provide in the Lego robotics kit that would make the Legos actually move together and do cool stuff. And so it's really been a lot of fun figuring out how to make the tedious things that exist in the IT world so much easier and more predictable with ServiceNow. And in my spare time, I like to hang out with my family, play pickup hockey, and video games.
Awesome. All right. So we'll start off with kind of a high-level overview of what cloud native operations is. We talked about it in depth last week. Well, at a high level last session, and then today it's going to be super deep dive. So, what is it, right? And this in italics here, this is the blurb from the store app page, which we'll include a link in and send out to everybody. But really, ultimately, at its core, it's a solution to quickly deploy and maintain, right, the entire ITOM stack of capabilities within a Kubernetes cluster, and it really dramatically streamlines discovery and health and service mapping, and all of those capabilities as we're managing a Kubernetes cluster. So just at a high level benefit, right? I talked about it's highly streamlined, much easier to deploy and manage. It actually makes some changes to the discovery patterns so that the Kubernetes discovery patterns don't require a credential. Instead, it utilizes a Kubernetes service account that it assumes in order to do all of its discovery components and authorize against the API, which is just flat out a better and more secure method. It also changes the way that we can discover resources within the Kubernetes cluster. Instead of running patterns every couple of minutes, it actually uses an agent script to run locally and ingest events from the cluster in 60 seconds or less. So it's much faster and it's more streamlined. And then the last piece is it has an automated deployment of the agent client collector. And if you're not familiar with the agent client collector, it is our kind of an all-in-one agent for visibility and health and log ingestion. So we use the agents to discover the Kubernetes nodes themselves. We use the agent to ingest metrics and logs from the pods. We use the agent to discover traffic patterns as traffic is communicated back and forth between the pods and services on the cluster, and then make recommendations for service maps based on that. And then we can also use it. We don't have it configured in our demo today, but we can use it for log ingestion for health log analytics. And as always, it's informal. If you have a question, feel free to come off mute or raise your hand, jump in if you have anything you want to add or ask. So, Will, do you want to kind of talk us through the architecture here?
Yes. So, as Mike will get into when he kind of walks through the install process, the way this Kubernetes bundle is delivered from once you've installed the store app in your ServiceNow instance is there's a deployment page which produces some one-liners, and there's install and remove one-liner for straight Kubernetes and then one for OpenShift. And what that one-liner essentially does is it retrieves a template YAML file from your instance, and then it runs a little prep script that prompts you for things like the mid-user credentials and the API key for the mid-server WebSocket endpoint. And it basically uses that to fill in the template. And then it generates something like what I've got in this diagram here when you deploy it to your cluster. And so what that looks like on your cluster. So right here, we've got our, we've got our cluster up here, and let's see if I can annotate. So we've got our cluster here, and then for sake of this kind of example, we've got 4 nodes. And so within each node, you end up with a pod that's part of a daemon set, which hosts our agent client collector agent. And that provides ServiceNow with visibility to what's going on inside each node. For example, what pods are hosted in it, and then what container images are being run underneath each of those pods. And then it also deploys a stateful set pod, which houses a containerized mid server and an ACC agent is in there as well to basically kind of keep track of what's going on with that mid inside the pod. And then, all the standard Kubernetes trappings are included along with that. So if, this mid starts to misbehave, we just kill this pod and it'll stand up a new one. All of the registration, which kind of out of the box, is done somewhat manually as far as, if you deploy a mid to a server, a standard server, you generally would have some manual steps involved with installing the mid package and then validating that mid once it reaches out to the instance. And that's all done automatically within this Kubernetes bundle. It also defines secrets with which to store the authentication tokens, such as the mid user and password, as well as the API key used by the WebSocket endpoint. And in terms of communication, I've kind of drawn that in with the green and red arrows. So the green arrows represent communication between the agent client collector and the mid server that's running inside the stateful set pod. And then the mid server is communicating via the, indicated by that red arrow, back to your ServiceNow instance, just like any other mid server would.
Makes sense. Any questions kind of about what the architecture looks like? All right. So I will go ahead and actually jump over to my instance and show you a little bit about, I have to clear the annotations first.
I can do that.
All right. So once you actually, here, let me start with the store. So in the store, this is the Cloud Native Operations application itself. You'll go here and you'll see, as of today, it is only compatible with Rome. So if you've moved over to San Diego already, hold on, and my hope is we'll have a San Diego capable version soon, but we're not there yet. So right now we have version 2.4.3, and the key thing is there's this user guide here is actually quite good on how to install it and set it up. It talks through the creation of a user necessary that has some specific roles that it needs above and beyond what a normal mid server needs, because this mid server is actually creating services on the fly for you, as well as building up event management integrations on the fly for you. So it's a little bit different from a standard mid server user. There's also a couple of other components. There are a couple of stateful sets that you can that need to be added to your instance. One is absolutely required for it to work at all, and the other is if you're using the health log analytics capability. The stateful set does some changes to the Kubernetes patterns, and a couple of the update set does some changes to the Kubernetes patterns in order to remove the credentials requirements and a few other components. So once you've got that process done, you've got it requested and installed in your instance, you'll have this new cloud native admin section here, and you'll go to this deploy to Kate's cluster here, and you'll see this is really just a shell script, essentially, right? That is going to pull down the config off of your instance and save it to a local YAML file, and then it'll pull down an actual shell script called SN-apt deploy to run through and ask you those very common questions, those configuration questions. And here we can just quickly do it. I won't actually complete the deploy because I've already got it up and running in my cluster, but it asks you, hey, what instance do I want to connect to? You can say, then this is the username that the mid server will log into the instance as. So for now, again, since we're just doing testing, I'll do that. Oh, and it's going to fail because it actually reaches out and validates, hey, is this username and password correct and accurate? And does it have all the right roles? So we won't try that. We won't go through the completion of that. But once it's there, the next thing it's going to do is ask you for your API key, which it gives you a link to go to your instance and copy the API key down, and then go. Once it does that, it will. Oh, it also asks you what namespace you would like resources deployed into on your instance. So I put them in the ServiceNow namespace. So we can see here are the pods that are currently running in this namespace. Looks like I've got one ACC agent that it's trying to restart. But all the rest of the ACC agents are up and running. And you'll notice the mid server is running, and 2 of 2s because it's got its sidecar mid server as well. So now that's up and running, we can actually go back to the instance and we can go to, there's this new Kate's mid servers, right? So from here, these are the Kubernetes mid servers that have been deployed using the Cloud Native Ops Toolkit. And this is the one that we're running on here, and you can see it's up and it's running. It comes up automatically validated. It comes up very quickly, and it comes up with the agent client collector web interface already up and configured on it. And so at the same time, it also deploys agent client collector agents as those as a daemon set across each of the nodes in your cluster. And so these are those Kate's agents that are deployed, and you can see here, here's where it's collecting data. It looks like this is the one that was having issues, so we'll go ahead and see if we can get that to restart. Just quickly resume data collection. And then as those are up and running now, they'll start ingesting metrics and traffic from that cluster. So if we go look at the Kubernetes dashboard, so this is the cluster that it's currently deployed in. It's got 6 namespaces in there, and just for example purposes, I deployed the boutique app, which is the microservices demo from Google, in the default namespace, just so for testing purposes, and so we can see some traffic and see one of the things that are going on. So these are all of the services and pods that make up that application. You can see actually some of them have incidents already against them, and we can go and dig into that here momentarily. From there, we are actually ingesting metrics from each of these components already, and we also can do tag-based service maps. So one of the things that it also shows here in the Cloud Native is this service map candidates, right? So by default, it filters out cluster IP services, because generally cluster IP services are only available within the Kubernetes cluster, and they are not externally facing services. But in this particular case, since we're not actually managing a public application, most of my services are deployed with cluster IPs. So I'll turn off that filter so I can see all of the potential tag-based service map candidates. So each of these are services that it's recommending be built based on traffic patterns and tags. And you can see here's the cluster ID that it came from. So I'm primarily working on cluster ID 616 right now. So for instance, if I wanted to say, okay, I want to actually create one from this product catalog service, I can click on that. And I can say, oh, okay, here's all the components. Okay, that makes sense. I'll go ahead and click this Create Application Service button out of it. And that'll actually create an application service for me and automatically build out the service map based on the tags that are ingested from those CIs. This is a very simple, straightforward service. It's a Kubernetes service here on the front end, and that is backed by a single pod called the product catalog service pod, right? This is really a microservice, and all of those, multiple microservices that get deployed in that microservice demo app all roll up into what we call the boutique shop. And so just to make that kind of more visible and make a little bit more sense, I built a tag-based service out of the entire service called boutique. And I did that. If we go look really quickly here. If we look at the manifest for the microservices demo that I deployed, I added this label for each of the components called tech service is the key and boutique is the value, right? That way, and this is something that should be done as a standard practice across all development cycles, right? Is really every resource should have a standard labeling convention and be managed via labels. Rizwan, yes, we'll absolutely record this and we'll ensure that we post it. We actually have a YouTube playlist for all of these recordings. We'll make sure we send that out with a follow-up email after we wrap up.
Mike, I'll throw the link in chat too.
Oh, perfect. Thank you.
You're welcome.
So I've gone through and added those labels so that way we can kind of group all of those microservices into, in my nomenclature, a technical service called boutique, right? So now I've then built a service map based on that. It's really straightforward. You go in and say, hey, tag category is tech service, right? And then build out that tag-based service map based on those tag categories. We can dive into tag-based service mapping if we really want to. But for now, suffice to say, let's actually look at the actual map of those services. So this is the boutique shop, and I'll can I minimize that? That's odd. My sidebar.
There should be an arrow that
it's missing down here. Oh, there it is. It was just super hidden.
There you go.
All right. There we go. So from here, you can see here's our boutique shop. And here are the various services on the front end. We've got an internal front end and an external front end. We've got our checkout service, email service, and each of those services is backed generally by one or more pods. And in one particular case, we've got this load generator pod. That's part of the microservices demo that does not have a front end service because it's not intended to ever be accessed by anything else. Its whole job is to just run around and send traffic to everything else in the microservices demo so that we can see how things are operating. So, and I'll show you. So this is actually that online boutique shop, right? I can kind of click around here and I can say, sure, I'll buy a tank top, and why not? I'll throw in a candle holder while I'm at it, right? So I add both of those to the cart. I'll go ahead and place my fake order. Hooray, my order has been placed. Good stuff. So that all of that was all done and supported by all of these various microservices in the background. And if we want, we can actually go into kind of the service monitoring section here, and we can look at the metrics that are being ingested from any of these various components. So if I go click on metrics here, and let's see here, sure, let's go look at the shipping service. And I can say, okay, right, here's my HTTP operations per second, right? It's hovering pretty steadily. That's mostly because of that load generator pod that's in there. It's just kind of randomly banging around on that website and making sure that these graphs aren't zero. But we can go through and we can look at any of those metrics. We can look at the Insights Explorer for metrics, and we can map all of these components in. In this particular case, we're using Prometheus on the Kubernetes cluster to actually scrape those metrics and then ingest the metrics from Prometheus. But there are other various ways to do that the agent client collector supports as well if you're not using Prometheus. So that's kind of a high level around kind of the deployment, the discovery process, and a tag-based service map and some of the ingestions. But let's take a look at maybe what's going on the operator workspace and see if there are some incidents that are going on. It looks like I actually do have one because that's now red, but let's take a look. So my boutique app, as it reloads here, it's currently red with a severity critical. All right, and we've got multiple alerts that are associated to this. And it looks like I've got a particular node in my AKS cluster that's having some resource constraints, right? Which is actually causing some of the pods to not be scheduled properly. Right? 0 of 5 nodes available, 1 has insufficient CPU, and 4 nodes didn't match the pod's node affinity selector. So it couldn't get scheduled properly. And that's just simply because of the way that service is set up. We could go in and tweak it if we wanted to, but it's actually nice to see something break, right? So we can see the events get generated, we can see the incidents being happened, and we can actually go in and, if we want, kind of kick something off. One thing I thought I might do really quickly is, let's do this. Let's say, hey, this is my production version of this particular application, but I actually want to deploy a dev or a test version, right? So let's just make a copy of that manifest, and we'll call it manifests dash test.yaml, right? And then let's just go ahead and change that one label. Probably just do it easiest with a sed. Tech service boutique, and we'll replace it with tech service boutique dash test. Okay, and globally on every line, and Kubernetes. Of course it's going to be difficult. That's fine. What did I miss? Oh, different command on a Mac. That's fine. Don't worry about it. I'll figure that out another time. I'm too used to doing that actually in a Linux pod. Let me try that again. Man, too many things going on here. All right.
Curse you, bash history.
Yep. All right, so let's just do this. Boutique. Okay, done. And then let's create a new namespace really quickly. Okay. Let's actually put it in the namespace of boutique test. Okay. So it's going through now and deploying that boutique app in that boutique test namespace. And now they're all labeled with tech service boutique-test instead of boutique. So let's go ahead and check our pod deployment. Okay. We'll watch and wait for those all to come up.
So just to point out one thing, for those of you who have done kind of the traditional pattern-based discovery of Kubernetes, there's the documentation tells you to set up two different schedules. One to run the generic or the cluster level Kubernetes discovery, and then one that runs more often that runs a pattern called Kubernetes events. When you're using Cloud Native Ops, the Kubernetes discovery pattern still runs on a daily basis as kind of normal, but in the place of the periodically launched Kubernetes event schedule, there's actually a agent client collector check, basically a script that executes on the agent client collector that's associated with the mid server in that stateful set pod, which performs the same actions as the event-based pattern, with the difference being it's more efficient because it's running from within the cluster itself and just pushing those events out versus polling the cluster from an external mid server to try and pull those events out. So it kind of gives you a more responsive and accurate CMDB because it's pulling those events from within the cluster and pushing them into your CMDB. I think it's set up by default every 5 minutes. Is that what we saw when we looked at the policy earlier today? I think
every 60 seconds. But
60 seconds? Okay, yep. So it's pretty responsive in its ability to detect changes to the cluster.
Yep. Yeah, so if I look for Kate's here. Yeah, so here's this Kate's events check that it's got configured. And it's registered to both of my mid-server agents. And where did I see that timing? Oh, hang on.
Is it on the check instance tab? I'm trying to remember as well where we saw that.
There it is. Yep, you're correct. Here it is. Every 60 seconds. So it goes fairly quickly. So now if I go back to my Kubernetes dashboard again, I now have 7 namespaces instead of 6. And here's my boutique test namespace. And all of those pods that were just deployed. And let's go back to Cloud Native and look at service map candidates. Oh, right. So these are all going to be duplicates. I actually need to go to tag based because I specified this tag based instead of traffic based, which is what that's looking for. It'll fall under this Mike's apps. So let's look at view candidates. Oh, actually, let's recalculate, update the candidates. And here we go. There was boutique test. Map it. All right. So now I can go quickly recalculate it. Something odd is going on with my UI. That's okay. All right. So let's go back to tag-based services, boutique test. There we go. List out those CIs. There we go. There's our pods. Here's our cart service. Right, here's our services. Let's, oh, actually, that's not what I wanted to do. I wanted to actually go and view the map. Right. I have a slightly different depth configured here, which is why it's showing slightly differently than the last one. But it's the same effective data, right? We still have the pods, we still have the services. It's all there. Another interesting thing to point out that we didn't talk about earlier was the tracked configuration files. So I've got this configured to actually pull in the YAML files that are being used to define and instantiate these. This one has not pulled it in yet. So let me go back to the boutique service because I know I saw them on the boutique service. Man.
Yeah, the YAML, I'm pretty sure the YAML extension only excuse me, only runs when the main Kubernetes pattern runs.
Got it.
So it would by default it's only going to get picked up once a day.
Right. So we can see if I click on one of these, we can actually go down and look at, here is the JSON that's ingested that has the YAML file for that service. And because that's a tracked configuration file, we will store that and we'll store changes to that. So if we were to go and make a change and then rerun the total Kubernetes pattern, the complete pattern instead of the event-driven pattern, we would actually see that get ingested and we would actually be able to track those differences. So we've walked through the deployment, we've walked through the discovery process, we've walked through metrics ingestion, we've walked through kind of alerts and incident creation based on that. Will, anything I've missed that you think we should touch on?
I don't think so. I think that's a pretty good overview. Like Mike said, shout out anytime or put in the chat if you have any questions. One thing that, since we got plenty of time, one thing that's probably worth talking about is how readily this kind of thing could be incorporated into like an automated cluster, deployment, CI/CD pipeline, that kind of thing. Since kind of out of the box, what the instructions tell you to do is, pull down that one-liner and then execute that and respond to prompts.
Yep.
So actually, if I can grab the screen for a second, I can just kind of show how that could pretty readily be incorporated into a CI/CD pipeline. Okay. You see my screen okay?
Yep.
Terminal window?
Yep.
Cool. So down at the bottom here, I've just kind of pasted in that one-liner as delivered by the instance. And so what I did to kind of create my own customized version was two things. I basically just deconstructed this command to initially, I just broke it down into the two component parts. So I took the first curl command that's in the one-liner and just executed that. And what that gives you is a copy of the template that is downloaded from the instance. So normally this is downloaded, it's processed, and then it's removed, cleaned up by the one-liner. So in order to kind of, inject your own customizations, all you have to do is just make a copy or save a copy of this. Then the second thing I did was I went back to that one-liner, hash history. So I went back to the original one-liner and just deleted the front part. Like this. And then I just redirected that to something like this. That basically pulls down the install script, or the formatting script that we run. And then once I had a copy of that, I just went in there and just modified the end. So it's basically, just prompts for those various credentials that are required in the instance name. It allows you to do things like configure a proxy if you want the mid to communicate with with the instance over a proxy. And then at the end, it would normally run, kubectl apply, and then it would clean up after itself. So I just kind of invalidated those last two commands and then executed the script by hand. And this produces the same prompts that Mike went through earlier, and ultimately it basically just updates this template file so that it contains, fills in the blanks with the values that you provide via the input. So once that file's created, I've now got kind of a standalone file that I can execute multiple times over to push out a standardized cloud native ops configuration without having to go through the same process over and over. And that Kubernetes manifest can be, propagated to any number of different clusters. So what that looks like is something like this. Let's see. Oh, it looks like I was too smart for my good. It cleaned up after me. All right, so I'll have to actually go through the full exercise here. Okay. Okay, so as Mike mentioned, in order to get it to complete, you have to kind of give it valid credentials, because otherwise it won't successfully verify it's able to connect to your instance. So retrieve my API key from my instance. So for example, if you're going to automate this, you would probably just put those values immediately into some kind of a credential store and then just instruct your Kubernetes cluster to pull them from there versus putting them directly into your deployment. But really what's nice is once you've got your this basic file, you can basically take this starting point and then customize it as needed for your specific implementation, and it gets you out of having to manually kind of run through that scripting activity every time. An example we ran into was Mike was having an issue with some the default resource allocations that were being provided to the ACC pods. And one of the ways to fix that would be to customize the agent client collector configuration file that's part of this image. And a way to do that would be to create a customized image by pulling down, this base image, making the requisite modifications, and then pushing up a customized image to your own container repository. And then you would just go into this manifest and modify that container path to reflect your own, private repository, as opposed to pulling the one from the public ECR, which is what the tool does out of the box. It also provides, also gives you the ability to apply additional tagging if you so desire. Really basically anything that you would normally do with any other, Kubernetes workload definition. So it's pretty straightforward and lends itself to automation pretty easily.
Yeah, great question, Jim. Jim asked in the chat if this is ready for AKS, EKS, and GKE. So, um, the I have a customer right now who's actually going through and doing this process and added into their Azure DevOps pipelines that actually goes through and builds out the whole manifest and pushes it into their GKE clusters. I have deployed this on AKS, EKS, and GKE, and I have not had any problems with any of those. There's a couple of things that I would say are oddities. Like we're using the agent client collector to do things like look at free disk space on the Kubernetes nodes, which makes sense on a cluster that you're managing, but on an AKS cluster, that's really up to Azure to ensure that your node has enough free disk space, right? That's not generally something that you need to be too terribly concerned with. There was one other oddity. In general, Azure AKS does not have it does not expose the Kube controller manager, and that's something that we look for as part of the standard pattern, and so therefore it kind of squawks about that when you try and discover that. But that's not a deal breaker and is generally just kind of a minor annoyance and is not unique to cloud native ops. However, here is the part where we have an ask of you guys. If this sounds interesting, please go to the idea portal and say, hey, we really would like to have cloud native ops pushed to GA. As it stands right now, it's set for GA in Q4 of this year, and I think it would be beneficial for lots of folks to have that pushed earlier and get more kind of development focus on it. So that would be my ask. I have actually one other ask really quickly, and I'm going to shift gears to talk about it, and that is around having an immutable container. I will share this idea out, but this is from a customer who is using our container Docker file that we provide and deploying it, and their security team is rightfully saying, hey, this container image doesn't follow Kubernetes container best practices, which is really that your container should have a read-only root file system. And then you can mount kind of a stateful storage or some kind of other storage if you need to have things that can change. But you're not really, best practices, you're not really allowed to change the root file system of a container. And the problem with that is, as it stands today, the mid-server code very much is used to running on, I am on a VM or I am on a server. And so I have the ability to write anywhere and everywhere. And so as a result, it assumes that the container that it's running in is in read-write mode. And so they have put in this idea to have us focus some development efforts on developing an immutable container for a mid-server that would have the ability to move all of its read-write functionality to a specific directory or a specific location that can be done and defined in a safe and secure way in Kubernetes. So I'll throw the link to that in the chat if you guys wouldn't mind throwing a few upvotes on that. That would be great, because then we can get some more development efforts focused on that.